Now we're recording. Oh yeah, this is going to be epic. All right, here we go. Okay, my friends. So, this is a rational function. We know it's a rational function because there's a variable in the denominator. All right? So, we have f of x equals 2x plus 1 over x plus 1. And there's a whole lot of stuff that we need here. And you have notes in Canvas for you. And I would definitely use the notes as you do the problem until you get pretty good at them. All right. We know that the parent looks like this. It's those two curves. And the reason why the parent is that is because the equation is f of x equals 1 over x. And if x is 0, it's undefined, correct? You can't have 0 in the denominator, true? All right. So, what number would make this denominator 0? Negative 1. So what you just did in your head, very quickly, was you just said that if x plus 1 is 0, then x would equal negative 1. Correct? Awesome. Great. Good. So what we just found is the one place that x cannot be. So what we have just found is a vertical asymptote. Vertical asymptote. And asymptote is spelled A-S-Y-M-P, asymptote. We just found a vertical asymptote. What we found is a vertical line, x equals negative 1. So, on the graph, give yourself a y-axis and an x-axis. So there is your y-axis, and here is my x-axis, and I just found the line x equals negative 1. So my graph can't ever touch x equals negative 1. So I'm going to put a dotted line, x equals negative 1. And it's dotted because it can't be part of the graph. And so it's going to be dashed. And how did we find that? We decided where the denominator would be 0, where the fraction would be undefined. So now we can talk about the range. Every number in the whole wide world will work except that one. So we can pick x equals negative 1,000. We can pick x equals negative 1,000,000. We can pick x equals negative 2. We can pick x equals negative 1.1. We can pick x equals negative 0.9. We can pick x equals 5,000. We can pick x equals anything in the world we want except negative 1. Because if you put negative 1 in there, it's undefined. So our domain is everything but negative 1. We can't write it that way because we're not in Algebra 1. We're in college algebra. We can't say everybody but negative 1. So for your domain, you're going to say negative infinity to negative 1, negative 1 to infinity. That's math speak for everybody but negative 1. Okay? Everybody cool with that? Awesome. Okay. We are also going to find that there might be a horizontal asymptote. And horizontal asymptotes is the one people struggle with because you have rules for that. And the rules are listed in your notes. Horizontal asymptotes are decided by comparing powers. Comparing the highest power in the numerator of the fraction to the highest power in the denominator of the fraction. So right now in this problem, we have x to the first power in the numerator, and we have x to the first power in the denominator. Does everybody agree those are both first power x's? Excellent. When the powers are the same, your horizontal asymptote is the quotients of their leaders. So the leader of this polynomial is 2, and the leader of this polynomial is 1, correct? What is 2 over 1? 2. So our horizontal asymptote is y equals 2. So our horizontal asymptote is y equals 2. So guess what the number is that you can't ever touch as you move from the floor to the ceiling? 2. So now you're going to put a vertical line and you're going to dash it because it's really not part of the equation. You're going to put the vertical line y equals 2 and dash it. So that is y equals 2. So FYI, let's go away from this lesson for half a second and go back to something we did in October. When we started talking about translations. The parent has asymptotes of the axis system. The parent has 0, 0 can't ever be touched. That's where the two asymptotes intersect. Follow that thinking? So that's where the parent isn't supposed to touch. The parent's not supposed to touch 0, 0. Okay? Our function is not supposed to touch -1, 2. So if you were asked what the translation is, it's been moved 1 to the left and 2 up. So I could have started asking you that question back in October when we did translations, but I didn't ask them a lot about rational functions because you hadn't talked about rational functions yet. Does that make sense? But now you can expect to see those things, all right? So it's supposed to look like this around the axis system, and instead it got shoved left and shoved up. Everybody cool with that? By the way, it's stretched by a factor of 2. Everybody see that also? Okay, let's get back to today's learning. Okay, so we have a pretty good idea. So we know that we're going to have a curve that comes in like this and a curve that comes in like this, but we are going to hit the x-axis somewhere, and we are going to hit the y-axis somewhere, so we need to find out where those somewheres are. Okay? So let's think about this. Let's find the x-intercepts first. So if you remember, x-intercepts are along the x-axis, correct? So along the x-axis, the value of y is 0. True? So if we're going to find the x-intercept, we're going to remember that that means y equals 0. Everybody on board with that thinking? So this is our function, and we're going to say y is 0. So we're going to say 0 is equal to 2x plus 1 divided by x plus 1. Because I want to know where this curve is going to hit the x-axis. And if it's on the x-axis, it has a value of 0 for y. Or y has a value of 0. So this is our algebra problem. If you go way back to August, one of the very first things we learned in this class is how do you get rid of fractions? You multiply by the denominator, correct? If you multiply 0 by x plus 1, what is 0 times x plus 1? 0. Is that problem easier to look at? Okay, now when I was in high school and my friends said, oh, just ignore the denominator, I was like, you just can't erase part of a problem. Does everybody see I didn't erase part of a problem? I multiplied by the denominator, and multiplying anything by 0 is 0, yes? Excellent. So now we're going to solve this problem. So what's x equal? Not quite 1/2. -1/2, yes? All right, so x equals -1/2. So x equals -1/2. So my y-intercept is -1/2, 0. So I know this has to hit the x-axis at -1/2, 0. So I know my curve has to hit there. All right? Excellent. I also know I need to hit the y-axis. All right? So we need to hit the y-axis. So let's talk about the y-intercept. The y-intercept, any number on the y-axis has an x value of 0, correct? That means the x is 0. That means we're going to substitute 0 into the problem. If we substitute 0 into the problem, we actually have that. And this is when I was in high school, my friend said, oh, just ignore everything that has an x in it. What are the only numbers in the problem? And I was like, why do we get to just ignore stuff? Well, we're not ignoring stuff. If you put 0 in here, what's 2 times 0?
0.
And what's 0 plus 1?
1.
So the only thing that survived was the 1, yes? And then what's 0 plus 1? 1. So the numbers in the problem give you 1 divided by 1, which is 1. So the y-intercept is 0, 1. So on the y-axis, we're going to intersect the y-axis at 1, which is what happens if you just ignore everybody that has an x in it and you look at just your numbers. Okay? So that's how my friends that understood math came up with those shortcuts. And by now I was just like, y'all are talking a different language, I'm out. So 0, 1. So right there is 0, 1. Okay. Those 2 points I just plotted, if you think about the red and the purple lines, think about your asymptotes. They're in the bottom right-hand corner of your asymptotes, correct? That means this curve has to do that. And then the reflection of that curve, if you will, has to do that. There's your picture. There are all your answers. Nowhere in there did we talk about the range. We could have typed in the range. The range is everybody but 2. So negative infinity to 2, 2 to infinity. Is there something you have in your possession that would give you a hint of what this graph is going to look like? Calculator. Let's do that. Bless you. Put it in your calculator and see if it kind of looks like that. That might be where you want to start, not where you want to end. Okay? Now, it won't give you all the answers, but it will give you the y-intercept. You can find that on the table. It's only going to give you the x-intercept if you either use the trace key or you change your window settings, right? If I don't have your screens closed, you could have just typed it in Desmos. Yes? You could have just typed it in Desmos. Cool? And if you type it in Desmos, I put 3 equations in Desmos. I put the function in Desmos, and then when I think I know what the asymptote is, I put the asymptote in Desmos to see if I'm right. And then when I think I know what the other asymptote is, I put it in Desmos to see if I'm right. And then I can click the y-intercept and the x-intercept and they'll both be there. And then you're golden unless it gives you a decimal that's an irrational number. Then you have to do the math to figure out what it really was. Because sometimes it's not a pretty number like a half or 1. Okay? Fair enough? Just because I put these in a specific order in Canvas doesn't mean you have to do them in that order. All right? Depends on what you're given to what you know first. All right? Everybody cool with that? Fabulous. While I'm erasing, if you would like, put the next function in your calculator. Because not all rational functions are identical. Their shapes can be very different from other shapes. Does the shape look a lot different from our other shape? Yeah. Okay. So here we go. I always like to start with, well, that's not true. I always like to start by looking at the function and going, what do I know? All right. X squared plus 1. I want to know what number would make the denominator 0. So I'm looking for the vertical asymptotes first, because that's what I decided. Anybody remember? I did vertical asymptotes in red. So, just trying to be consistent. So if I take x squared plus 1 and set it equal to 0, I got an imaginary number, yes? So guess what there is not? A vertical asymptote. So there's not a vertical asymptote. In Canvas we put does not exist. All right? Those of you who put it in your graphing calculator, is there any place that's missing? There's no place that's missing. It's all there. As a matter of fact, it kind of looks like an inverted V, doesn't it? Something like that. Okay, so vertical asymptote. In Canvas, we would write does not exist. Okay, cool. All right, let's talk about horizontal asymptotes then. Horizontal asymptotes I did in purple. Horizontal asymptotes are the ones that people struggle with the most. Probably because I say that. That's not true, but because it has more rules. But it is a comparison of powers. It is a comparison of powers. And right now there's a handful of you sitting out there looking and saying, well, the 4 doesn't even have a power of x. Technically it does, but we don't want to write this because that would just blow your heads, right? Right off your shoulders. Just imagine if you were a little bitty kid and you were learning to count and you were like 1, 2, 3, no. It's 1 to the 0, 2 to the 0, 3 to the 0. How old are you? 17 to the 0. Right? Nope, that's not right. 17 to the first. Never mind. Ignore everything I just said. Whoops. Take that out of the video. All right. Oh, my hand was huge. Hi. Okay. 0 power is 1, right? X to the 0 power is 1. So it's a 0 power. Doesn't matter. Who's bigger? The numerator's power or the denominator's power? The denominator's power is bigger, correct? So the denominator's power is bigger, so that means y equals 0. That's the rule. The rule for horizontal asymptotes. Horizontal asymptotes, the rule is if the power of the denominator is bigger than the power of the numerator, then y equals 0. Every time, every time. Every time, every time. if the power in the denominator is bigger than the power in the numerator, every time the answer is y equals 0.
Okay, so regular quotient of the first two numbers, but if the power of the bottom one is larger, then it's 0.
If the powers are the same, it's the quotient. If the power at the bottom is bigger, it's y equals 0.
Okay.
And I'm very emphasis on y equals 0 because if you type 0 into Canvas, guess what color your box is going to be? Red, because it's a line and 0 is not a line, correct? So you have to type in Canvas y equals 0. Okay, so I haven't put an x and y axis in here yet. Those of you who graphed it, everything is above the axis, correct? Mm-hmm. Okay, so I'm starting my x-axis down here a little bit. So we actually found that this right here, not only is the x-axis, but it is also the line y equals 0, yes? Okay? So here's something I have to do right now or I miss it. If the axis system is the asymptote, in other words, if the graph can't touch this line, can I ever have an x-intercept on this problem? No. So right now, you need to write down that the x-intercepts do not exist. If the x-axis can't be touched, if this graph approaches the x-axis but never touches it, you can't have an x-intercept, right? Everybody with me on that? Okay. Good, so we got that answered also. Okay, so we need to find the y-intercept. All right, the y-intercept is when x is 0, true? The y-intercept is when the x value is 0. So if we're going to find the y-intercept, we're going to remind ourselves that that means that we're going to put 0 in the problem. I'm going to get this out of here, just because that's bothersome, and that's where I kind of lost my brain anyway. If I replace all the x's in the problem with the number 0, what do we have? 4. Because if this is a 0, what is 0 squared? 0. What's 0 plus 1? 1. What's 4 divided by 1? 4. So when x is 0, y is 4, so my intercept is 0, 4. So 1, 2, 3, 4. If you'd like a few other points to plot, we could do that, or you could just look at your table, or you could just sketch it now because you graphed it already on your calculator. But if you wanted, I'm going to pick f of 1, just because 1 is really close to 0. Everybody agree? So if I put a 1 right there, what's 1 squared? 1. What's 1 plus 1?
2.
What's 4 divided by 2? 2. So when f is 1, that's 2, yes? So I know I'm going to have the point 1, 2. By the way, if I go, oh, I didn't mean 1, I mean negative 1, is it still the same answer? It's still the same answer. And if I wanted to plot more points, I could. I don't need to. I have a general idea of what this is going to look like. It's going to be amazingly close to the x-axis. At some point, it's going to curve up. Oh, that's really not very good, but something like that. It's going to hit there. It's going to peak out there, hit there, and come back down. Is that kind of, sort of, what your calculator looked like? So we're good? Cool beans? And you answer all the questions that are in Canvas. You type them all in, call it good. When you take the JCCC test, you know how we did the graph. I gave you graphs, that's why you should practice the graph. You can use the calculator on the JCCC test, correct?
Mhm.
I would emulate that graph on the JCCC test. He's going to want to see work. There's your work, right? Professor Revere is going to say, show your work. This is your work, and then you plot what you found. Cool? All right. As I erase, put the next one in, please. Did you guys see that? You flip it over. Okay. So with this one, I'm going to look at it and I'm going to go, wow. Seems to me that x squared plus 3x plus 2 is a quadratic that's factorable. The other two problems we did not have anything that was factorable. This one does. And just like in all the quadratics that we just did, the standard form and the factored form tell you different things about your graph. Yep.
Can't we just immediately find the horizontal asymptote because the power of x is small?
Would you like to start there? Let's start there. Jesse says let's start with the horizontal asymptote because that's obvious before we jump in. Okay? And you're saying the one on top is smaller than the one on the bottom?
Yeah.
So what is it, everybody?
0.
Not 0.
Y equals 0.
Y equals 0. Excellent place to start. My horizontal asymptotes were what color?
You did.
They were purple. Gotta look over here. They were purple. I'm just trying to be consistent. So our horizontal asymptote is y equals 0. So, if y equals 0, what are we not going to have any of? X-intercepts. And in Canvas, we're going to type does not exist. All right? And that's not the order things are in Canvas. Because if I rearrange the question in Canvas to match the order you would do them in, I'm telling you how to do the problem. Okay? And what Jesse sees as this is my first step and what I see as this is my first step might not be the first step. Everybody agree? So I try to be consistent as much as possible. Everybody good with where we are so far? Okay. You know what? I think I'm going to go ahead and put that axis in then. And dash it so I remind myself not to look for the x-intercepts even though I did write that we don't have any. So there's the x-axis. That's also the line. Y equals 0. Put the axis in there too while I'm standing here with the straight edge. It's not really straight, it's warped because it's so old. Kind of like me, a little warped. Alright. This is the line. Y equals 0. Fabulous. You know, if we want to, we can find the y-intercept now, while it's in this form, because the y-intercept is when the x's are 0, correct? Okay, so the y-intercept are when we do the x's as 0. So if you replace everybody with every x with the number 0, what number do you have? 1/2. Because you put a 0 here, here, and here, everybody goes away and you get 1/2. Okay, so we know 0, 1/2 is going to be on the graph. So we know this point right here is going to be on the graph. Now let's factor. So right beside it, I'm just going to rewrite it again, but I'm going to write it in factored form. And you guys should double check Mrs. Leonard's math. Is it true that the factors of 2 that add to 3 are 2 and 1? Awesome. So I can find the vertical asymptotes now. The vertical asymptotes are the numbers that make the denominator 0. And really, we did this part of the problem in September. And you did it last year in Algebra 2. This would be -2, and this would be -1. So in Canvas, when it asks you for the horizontal asymptotes, you are going to type x equals -2 and x equals -1.
You mean vertical?
I do mean vertical. And I make that mistake so many times, and then when I go to graph them, I go back and catch myself. So your vertical asymptotes are x minus 2, x minus 1, and is it important that you put the x minus 2 first? Yes, because we go left to right, correct? Okay, so let's sketch those in. X minus 2. And x minus 1. This is x minus 2. Y equals x, no. Jeez. This is Leonard. X equals -2 and x equals -1. Okay, cool. Did we do that correctly? We did that correctly. Oh, we did not do that correctly. I see what I did wrong. Okay. My bad. And this is something I mess up too until I get to thinking about it. This is an asymptote. And here is why. That would reduce that. True? So we have created a hole. So, and this is the first time this has happened to us today. So we have a hole at x equals -1.
Is that a question that we'll get to? There will be boxes and holes.
There will be, and it's actually the first box. And the reason it's the first box, Jesse, is because it's the piece I always forget to look for. And so I listed it first to remind myself to look. Okay, so friends, this is when holes exist. Holes exist when you have a factor in the numerator that is the same as a factor in the denominator, and the fraction is then able to be reduced or excluded. Does that make sense? So instead of missing an entire line, I am missing a hole in the graph. Now, if you graph it in your graphing calculator, it will not show you the hole because the pixels in the graphing calculator are not small enough. It's not HDTV. If you look in the table, if you go right now and look at the table and you look at x equals -1, the table will tell you there's an error. Okay? If you put it in Desmos, Desmos won't show you the hole either because again, the pixels are too big. But if you hover over x equals -1 in Desmos, it will give you the ordered pair, -0, undefined. All right, and that's how you know you have a hole. Okay? You guys knew you had a hole, you didn't know that's what it was called, but you knew you had a hole because when I said you had 2 asymptotes, you didn't see them on your graph. You only saw 1. And so that's how you knew immediately something was amiss. I knew something was amiss because I have it up here on my computer and I haven't looked at it yet, and it only had one asymptote, one vertical asymptote. All right, and I was like, oh my gosh, what did I do wrong now? Okay, so, I think, well, we can talk about the domain. The domain is all numbers except -2 and -1, right? So the domain is -infinity to -2, -2 to -1, -1 to infinity. Because you still have to jump over, you're gonna have a error statement in your table on your calculator for both -2 and -1. So those are the two numbers that you can't put in, because those are the two numbers that make the function undefined. Those are the two numbers that put 0 at the bottom of the graph. Okay? I put in the horizontal asymptote, I put in the vertical asymptote. I know we're gonna have a hole. We graphed it, we know it's gotta go through here, but it can't hit the red line or the black line, so it's gonna come this way. So, plus you have it on your calculator so you can see it goes this way, correct? It does this. By the way, I'm then gonna come in here and on -1, I'm gonna erase it. And I'm gonna put a hole. And that hole is what you're not gonna be able to see on your calculator. But you will see it in the table. All right? Thank you for the save, Jesse. Yep.
Oh no.
Okay, stretching. You're allowed to stretch. Okay, while I erase, go ahead and put the last one. So I think Canvas has that list. Okay? I don't really remember what order it's in. It's me. You know, I don't have a memory. So, x squared plus 1 over x plus 1.
The top power is larger than the bottom power.
Jay just said the top power is larger than the bottom power.
The top one is x squared minus x.
X squared minus x?
Yeah.
Goodness, it certainly is.
Thanks for catching that.
Thank you. Oh, that would be really, really bad. Thank you. Okay, so now that I've written the function correctly, and Jay has noticed that the power in the numerator is bigger than the power in the denominator, when that happens, there is no horizontal asymptote. So we're going to put that the horizontal asymptote does not exist. So as far as horizontal asymptotes go, there can be none of them, or there can be y equals 0, or there can be y equals something else. There can be 0 or 1 horizontal asymptote, and the answer is either going to be does not exist, y equals 0, or y equals some other number. Okay? All right. Vertical asymptotes, you can have however many of them you want, however many it takes to make the denominator become undefined. So in the last one, we just had a whole and a horizontal asymptote, okay? All right. So, what do we want to get? Let's go for vertical asymptote. We already, horizontal asymptote. So vertical asymptotes are what make the denominator 0, correct? So if you take your denominator, which is x plus 1, and set it equal to 0, your horizontal asymptote is -1? No, Mrs. Leonard, it's not. What is it? X equals -1? Should we factor that? Will the numerator factor?
Yeah.
The numerator will factor. In all honesty, I like to factor. I like to have them both side by side so I can compare them to make sure I don't have holes. Because holes are my nemesis. Holes are where I have the hardest problem. Okay? So this is the factored form. That is the standard form. Will anything here reduce? Nothing will reduce, so are there any holes? No, so they don't exist either. Awesome. So we've talked about our holes, we've talked about our vertical asymptotes, we talked about our horizontal asymptotes. Let's talk about our x-intercepts. Our x-intercepts are when y is 0, correct? X-intercepts are when y is 0. And I've been doing that, I think, in, I don't know what color. X-intercepts are when y is 0. X-intercepts are when y equals 0. So we're going to turn this into 0. So that's going to be 0 is equal to x minus 1 over x plus 1. But how do I get rid of the fraction? Multiply by it, which just basically erases the denominator, correct? Because we're multiplying by 0. So that's what we really have. That's when I was sure I had lost my mind in 1980. Okay, so what does this x equal? 0, and what does this x equal? Okay, so we found our two intercepts, correct? Our intercepts are 0, 0, and 1, 0. And if our x-intercept is 0, 0, so is our y-intercept. Oh, and I think I had done those in purple. And then our domain is everybody but 0 and 1. Oh, yes, yes, yes. Oh, we have one more thing we have to find. We haven't had this yet today. And I think it's higher up in the order, so I remember you had a hand.
Yeah. If the x-intercept wasn't 0, 0, would the y-intercept be does not exist since there's no horizontal asymptote? Or is that not like the same thing as the x?
Okay, so this is, can I wait to answer that?
Yeah.
Okay. Remind me if I don't answer it.
Okay.
Okay? Okay. So our domain is everybody but 0 and 1. So negative infinity to 0, 0 to 1, and 1 to infinity. Alright. So, and I didn't graph anything. I didn't even get graph paper out. Oh, there I did. Okay. When your power in the numerator is greater than your power in the denominator, when your horizontal asymptote does not exist, you have what is called a slant asymptote. In other words, you have a diagonal line. Why they call it slant instead of diagonal, I don't know. Actually, they call it oblique, but let's throw one more word in there. right? So the way we find the slant asymptote, everybody saddled up, ready for this answer? To use long division. But the division problem isn't horrible, but we're gonna use long division. Alright, so here's what we're gonna do, and I'll do it in purple, just so maybe it'll stand out a little bit. We'll do it right here in this spot. The divisor is x plus 1. This is x plus 1. Bless you. This is x squared minus x plus 0. Highest power of x, next power of x, no power of x, yes? Okay? Liter divided by liter. What is x squared, the lead term of the dividend, divided by the x, which is the liter of the divisor? What is x squared divided by x? X. So we put x right there. Then we're going to multiply. X times x is x squared. X times 1 is x. Then we are supposed to subtract, which makes that negative and that negative. What happened to these two terms? They cancel. What's negative x and another negative x? Negative 2x plus 1. 0. Sorry, my brain. Then we start again. Negative 2x divided by x. Negative 2. We can stop right there. Our slant asymptote is the line y equals x minus 2. So I probably should have started graphing this before, but we'll do it now. Okay. X-axis, y-axis. I don't want my x-axis up here kind of high. X-axis. Y-axis. I might have needed a bigger piece of graph paper. Hard to say. Vertical asymptote, x equals negative 1. So we cannot touch x equals negative 1. Slant asymptote is the line x equals negative 2, correct? So, the y-intercept is negative 2. And the rise is 1 over 1. So the slanting asymptote is this dashed line. So that is the do not touch me line, y equals x minus 2. We know we have an ordered pair at 0, 0. We know we have an ordered pair at 1, 0. And this is where Desmos is going to give you so much better picture probably than your graphing calculator. But this is going to be a V that nestles between the red and the purple. Yep.
How exactly did you write down the purple?
So we did long division
Yes,
and our quotient, and we didn't have to finish it. We just had to get it to look linear.
I got that part.
So that's y equals. And so this is where it crosses the y-axis, and that's our slope. Go way back to algebra 1.
Oh,
Okay? That's okay. You put it on your graphing calculator, y equals x minus 2, and it'll show it to you.
Yeah.
And you put it in the same graph as the other one, and then you'll have your
it was just
asymptote.
negative 2 by 1 by 1.
Yep.
and grid, yeah.
And so this is gonna be kind of a V shape that's gonna slide between the red and the purple. So it's gonna do something like that. Maddie, do you remember what your question was? Oh, with the horizontal asymptote, with the,
Yeah, like, I was, cause when there's no,
so I see your point. So not having a horizontal asymptote is different from the asymptote of being y equals 0. So when the asymptote is y equals 0, then you can't have an x-intercept because you can't touch the x-axis,
okay,
okay? But this doesn't have anything you can't touch
okay.
as far as a horizontal line would go. All right. Okay, friends. Is it simple? Absolutely not. But you know all the little bitty pieces, okay? And you have your notes also. So I would use your notes. I would use your graphing calculator. I would use Desmos. I would use whatever it takes to get these flowing for you. All right. And the good news is the test you're taking next Wednesday, Thursday, this is not on it because it's over something else, 3.7, 3.6, just over 3.6. So synthetic division, well, finding zeros, and this is not on it. But long division is, and all the quadratic stuff and polynomial stuff is. All right? Good Lord, that video is 51 minutes.